In this video, we're going to hook up to the crankshaft sensor, then we'll hook up to the intake cam sensor and the exhaust cam sensor. We'll determine the relationship between these three signals. This is a close-up picture showing the crankshaft connector and the back probing on the signal output signal, which is the red wire. We only have a 2-channel scope, therefore in the previous video we demonstrated the difference between the ignition firing of cylinder number 1 and the sync slot, the crankshaft signal. Here you can see the intake cam signal on the top and the crankshaft signal on the bottom. Here we're going to measure the standalone positive pulse on the top waveform and reference it to the sync gap on the bottom waveform. Here we can see that the isolated positive pulse on the cam signal is between the 8th and 9th sync pulse slot of the crankshaft signal. So now we know the relationship between the crankshaft and the intake cam. Once again, because we only have a 2-channel scope, we have to look at the intake cam on top and the exhaust cam on the bottom in this view and determine their relationship. This first zoom level demonstrates that the two cams are nearly identical in their patterns. Using the horizontal rulers, we can measure that the exhaust cam leads the intake cam by about 3.5 milliseconds. So in conclusion, we're now able to determine the phasing between the ignition number 1 firing, the camshaft sensor signals for both intake and exhaust cams, and also the crankshaft sensor signal. We now have the correct waveforms for all these items. That concludes this video.